Good morning everybody. Today we are going to discuss about the Ethernet medium access control sublayer protocol. Before going to the details of protocol, try to understand how data transmission will happen in this layer. Suppose if you consider two stations A and B, packet is delivered at A at time 0. It reaches B. So to reach B it takes time tau. Suppose something happened wrong at B, collision can happen. So this collision you want to detect at station A, you need further tau time because you have to travel from B to A. So almost if you see the total time to detect this type of collision, we need 2 tau. So collision detection time, maximum time is 2 tau. Less than this also it can happen, so that you can get the collision happen information. This is the event scenario in Ethernet MAC sublayer protocol. Now the technology here is we work out with carrier sense multiple access with collision detection. This is the protocol we use. So what do you mean carrier sense multiple access? Before sending data, first you have to sense the channel. Channel is ideal or probability of transmission is 1. Suppose channel is busy or probability of transmission is 0. So that is the reason we name that is one persistent protocol. This one indicates channel is ideal, probability of transmission is 1. Channel is busy, probability of transmission is 0. So that is the reason this is named as one persistent protocol. So that is the meaning of carrier sense multiple access. Here additional feature is collision detection. Suppose if you detect the collision, immediately you have to abort your transmission. That is the beauty of CD technique. So even you can send a jam signal, so others can get this information. So collision happened information. Once you block transmission due to collision, when will you retransmit? So that is the question arises. So generally collision happened means two stations tried to send data. So once collision happened, anyway you are blocking your transmission, then the question rises, when will you retransmit the signal once again? So for that, one algorithm called exponential backup algorithm. So what do you mean exponential backup algorithm? Here, if a collision is detected, suppose you take ith collision, then you have to select the time slots, that is a 0 to 2 power I minus 1. Here I indicates ith collision. Suppose first time collision is happened, so your I value becomes 1. So 2 power 1 2, 2 minus 1 1, so it varies 0 to 1. So first time collision happened. So generally collision happened means at least two stations are trying. So these two stations select time slots either 0 or 1. So this is multiplied with 51.2 microseconds. So 0 51.2 microseconds 0, 151.2 microseconds 51 point. So if I pick this slot, I will transmit immediately. If I pick this slot, I will transmit after 51.2 microseconds. The same thing will happen with other station also. Suppose both the station pick the 0th slot, then once again collision will happen. Then we'll treat that type of collision is second time collision. Then I value becomes 2, then 2 square becomes 4, 4 minus 1 3. So now time slots changing from 0 to 3. So picking of same slot now by the both the station, the probability will be reduced. Why? Because number of slots are more. But here picking the same slot probability is high. Like this, here also collision happened. We can go for cube. So it varies from 0 to 7. Like that it will be extended. So like this we will try for up to 16 times collision. Beyond that we cannot handle that problem. That is the reason we hand over that problem to the higher layers. So this is the exponential backup algorithm. So basically your CSMA by CD already we have seen, that is the one persistent protocol, and collision detection possibility is there. And if collision happened, we have discussed exponential backup algorithm. Now we will see the state diagram. Suppose a packet is ready, then immediately we sense the carrier. Suppose channel is ideal, then I submit the data. Suppose channel is busy, I will not submit data. So suppose if I assume channel is free, then I am sending the data. So data is reaching. So at this location, we have detected collision. Collision detected, then you have to work out with exponential backup algorithm. Suppose there is no collision, then transmit another packet. So here it is no, so that is the reason we are sending once again packet. Suppose if it is yes, then you have to work out with the exponential backup algorithm, and your attempts less than 16, we repeat this exponential backup algorithm. And suppose if it is greater than 16, that will be given communication to the sender. So that is beyond capacity, then higher up, nothing but a higher layer will take decision there. So this is the way we can work out with CSMA by CD. Now collisions are caused when two adapters transmit at the same time. Basically your node is connected to the cable with the help of adapter. So based on your voltage differences, you can identify collision happened or not. Why? Because normal 0 value, normal 1 value already defined. When collision happened, automatically your voltages values might be different. So based on voltages values, you can identify the collision. So anyway, once collision detected, you are sending a jamming signal so that everything will be blocked. And actually, when you are transmitting data from one place to other place, so you have to maintain a specific length of data frame so that your first bit reach the last node in the LAN. That is the basic idea. So A's message reaches B at time t. Suppose B's message reaches A at time 2t. So A must still be transmitting at 2t. So this IEEE 802.3 specifies maximum value of 2t to be 51.2 microseconds. That is the reason we have multiplied with 51.2 microseconds of our time slots. That is either 0, 1, 2, 3 like that. This is the idea of the collision detection. Now coming to the performance of the Ethernet. Basically some station acquires the channel with the probability A. So we are familiar with the total time period, that is the 2 tau. Suppose forward as well as anything happened wrong, we want to communicate back to sender, we need 2 tau. So that is the mean contention interval within that particular station is acquiring the channel. This is the contention interval. Nothing but before sending data, this is the contention, nothing but sensing the channel to transfer the data. That is the contention period. Anyway, to transmit the frame, we need some seconds. So that is the mean frame taking p seconds. So that is the frame transmission. This is also frame transmission. This is the contention period. So nothing but accessing the channel. Suppose channel is ideal, then probability of acquiring station is 1. Suppose if you consider A1, then it becomes P by P plus 2000. So this is the efficiency of the Ethernet. Like this, we can calculate the Ethernet performance. Now, what are the different types of cables possible? So, if you see the Ethernet evaluation, so once upon a time, there was standard Ethernet with speed of 10 Mbps. Later, it switched to fast Ethernet 100 Mbps. But nowadays, most of the our Ethernets, either gigabit or 10 gigabit Ethernets, of capacity 1 Gbps or 10 Gbps. So basically, when you go to the higher data rates, automatically cabling plays a vital role. So generally, we use either twisted pairs or fiber optics. So based on the capacity of those twisted pairs and fiber optics, we can transfer data with high data rate. Now coming to the gigabit Ethernet, we are familiar. Suppose you take one building. So entire building we have one switch where this switch is connecting to another switch that is there in another building, like that we are taking here. So within this building you might have several possibilities, nodes or even sub LAN also you can create in this. Like that, this is the gigabit Ethernet design if you consider. In gigabit Ethernet, also we have cable possibilities, either fiber optics or twisted pair. So S indicates this is the short 550 meters, L indicates long 5000 meters, and C indicates copper, T indicates twisted pair, and unshielded twisted pair UTP. Copper case it is called shielded twisted pair. These are the various possibilities under gigabit Ethernet. If you see the 10 gigabit Ethernet cable also, same fiber optics and twisted pairs we use. But data rates and fiber optics modes, if you see, you can even transmit it multi-mode or single mode or twin axial copper wire or category 6 like this. So especially this category 6 you see, then the data rate here is 10 gigabit. So very high data rate here. So that is the understanding of cables and importance. So you want to further details on these topics, you can refer Tannenbaum Computer Networks or Data Communication by Ferojan or TCP by IP Protocols by Ferojan. So thanks for your attention.